Hello, Javed. Shall we start now? Hello.
Yeah, sir, we can. Yeah,
Okay, fine. So, Javed, this is
yeah.
about this advanced PCB design course, first class. Welcome to that.
Okay.
So, on that day, we discussed
Thank
about
you.
what we are going to learn in this course, right? You remember?
Mhm. Yeah, yeah. Thank you.
Okay. So, fine. Before going ahead, I want some clarifications from you. Can we talk about that?
Yeah, sir, we can.
Okay. So let me
Hmm.
tell you, see, our goal is simple actually. So whoever
Hmm.
joins this course, right, any student,
Okay.
we don't want them to push into service-based industry.
Okay. Yeah.
Service-based industry. We do not prefer this.
Hmm.
Maybe like HCL or whatsoever. You know, like since you have 1 year of experience, you have a mild idea about like what is the service-based industry and why it is so dangerous to get in there and all, right? So we will target the
Yeah.
students to get into product-based,
Okay.
product-based industry. What are the product-based industries? Currently here in this course, we will target embedded products.
Okay. Okay.
Okay. You know embedded products, right? Anything which has embedded processors on it are called embedded products.
Mhm.
Right from the TV,
Yeah.
right
Yeah.
from the washing machine, any appliances, any instruments, any process. So all of them comes in embedded products. So we will focus more
Uh-huh.
on sending our students into embedded based industries. Okay. Are you okay with that?
Yeah. Got it, sir. Yeah.
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 Now,
Yeah.
now in your case, I have certain okay. So now
Yes. Hmm.
you can hear me clearly, right? No technical issues.
No issues. I can hear you.
Perfect. Okay. I will erase this.
Hmm.
Okay. So Javed, in any of the product-based industries, right? There is something called as PDLC, Product
Hmm.
Development
Okay.
Life Cycle. And from
Mm-hmm.
PDLC, there are two things actually. One is HDLC,
Mm-hmm.
hardware development lifecycle, and software development lifecycle. Any idea on this?
Okay. No, sir. Not exactly.
Not exactly. Fine. So,
Uh,
see, assume that you have an idea. You are from electronics and
mhm.
communication or electrical and electronics?
Electronics and communication.
So, electronics and communication. Assume that you have an idea, some basic idea only, say LM7805 based regulator. You have certain idea on this. Assume
Mm-hmm.
that this is a product that you are going to sell this as. And
Okay.
whatever I'm going to tell you right now in all these classes, right?
Mm-hmm.
Everything is kind of important
Mm-hmm.
for the interview. Okay.
Okay.
So it is not only that, okay, I am
Yeah.
teaching some theory and then I'll go for PCB design. No, everything is important from the interview point of view. Okay. So please focus.
Yeah.
Uh,
Mm-hmm.
so think that you want to make a LM7805 small board that takes 10
Okay.
volts input and gives out, say this is 7805 5 volts output, maximum 1 ampere current.
Mm-hmm.
Assume that you will make a
Mm-hmm.
board. Okay. So there is something called as
Okay.
product
Yeah.
development life cycle. So this complete board you will be talking to uh, the to the person who are going to use it, the customer. Okay. So once the customer says that,
Mm-hmm.
okay, I need this product, you have a complete development cycle. Like you cannot build that product in one shot, right? You need a step by step, phase by phase development that happens in the industry, in the in the product based industries. So you're there.
Mm-hmm.
Okay. So it starts from the concept phase. Okay.
Yeah. Mm-hmm.
So it starts from the concept base. Okay, in the concept base, it is also called as
Mm-hmm.
POC, proof of concept. You have an idea, you want to prove that this idea works. To whom? To the management. I want to sell
Okay.
this
Okay.
board. So I want to say that this board actually works in the field. This is the proof of concept. So in this proof of concept, you use whatever you want. You use breadboards, you use multiple embedded boards, whatever is available, like Arduino, Raspberry Pi. You do all the sketching parts and all that. So your main goal here is the proof of concept to show that your product
Okay.
works. So what they do, once the proof of concept gets approved by the management, you
Mm-hmm.
go to the next phase, that is validation test, EVT, engineering validation test. You build a small board. This is the first development. This is the first board that you build. First board, first sample.
Mm-hmm. Mm-hmm.
In industries, these are called as A sample, or some people
Mm-hmm.
called as alpha sample also. Some people call it as alpha sample also. So you build an early alpha samples,
Mm-hmm.
and then you start testing it based on your own requirements. Since this is the requirement from yourself, I said you have an idea, so the requirement is from you only. So you will give the requirement, you will test this on your for your own requirement, and
Mm-hmm.
slowly you go to the next phase, that is you finalize, okay, this is the 1 ampere it is achieving, it is like achieving up to 0.8 ampere, then you tweak something, then you finally goes to 0.99 ampere, up to 1 ampere you will tweak. So it goes to the late alpha, that this is almost at the final stage.
Okay.
So from here on, actually your PCB designers come in. So once this late alpha comes, so the PCB design, you will give the design to PCB designers. From here, you will give this to PCB designers.
Mm-hmm.
Sorry, I'm using this pen and this pad, so my writing is not so good. I hope you can able to follow.
No worries. No worries. Yeah.
Huh. So what happens, the PCB designers will take your design, and what they do, they start building it as an actual product. That becomes your design validation test. Once the product is come, that is called as MVP, it is called as minimum viable product, what you can sell to the customer. So again, there also, you will start one DVT, phase 1, and then up to DVT certain phases, like until everything gets finalized. Okay. After
Mm-hmm.
this
Yeah.
DVT is finalized, that becomes beta sample. Okay.
Okay.
So that will be given to the manufacturer to manufacture that. So that manufacturer, whatever he manufactures, becomes the pilot batch. Pilot batch.
Mm-hmm.
So this batch is sent to the
Okay.
customer to test it in his systems, in that systems, and get the feedback. That entire process is explained in here actually. So see, it is starts from the
Mm-hmm.
either business and market research. You think about your competitors, other customers, and all that. You think about that, and you take a market research out of that, and then
Mm-hmm.
also the need, based on that you have certain idea or whatsoever. So you think of all that, and then you define the
Mm-hmm.
product. This is the product that I'm going to sell in the market, and you get the end user and other feedback also. Like you cannot simply say that, okay, I have thought about this product, so I will be selling, right? If it cannot be sold in the market, no use in defining the product. So that's why whoever uses that product, you will get the inputs from them and the feedback. Okay.
Okay. Okay.
So once this product
Yeah.
definition happens, there is something called as PRD, product requirement document. I will explain that later. There, every
Okay.
requirement is noted down, and this proof of concept
Mm-hmm.
is built around that requirement.
Okay.
Okay, say for example this one buck converter only. So what they say, okay, I need this to pass certain EMC test. I
Mm-hmm.
need this to pass all these certain environmental conditions. It has to work under certain environments like minus 30 degrees centigrade till 75 degrees centigrade. So there are certain things that they will give, and you will take it, do the architectural design, do the component selection and validation according to these requirements. That becomes design alpha, and design alpha goes for testing, converts to design beta, as I explained here at the starting. So at this stage itself, you do something called as pre-certification. The certifications are very important, like IEC. This is standard for all the machineries here. IEC 61000-X. That means 1, 2, 3, 4. I will explain once this concept comes in detail. This is a EMC compliance testing, EMC certification and compliance testing, pre-certifications. That means before going to the certification itself, you have designed the product and then you are checking for the pre-certification. In this certification, whether it will pass or not. You will get a crude idea on that. And then you build the beta on all this. At the same time, IP registration, crowdfunding, and all that you do. And once the
Mm-hmm.
beta comes out, you go for the actual certification. Trust me, in Karnataka, in Bangalore, especially in Bangalore, there are certain labs that they will do this certification. In order to do this certification, there are certain conditions that the lab has to have ISO 1717 17025 certificate. They should have this certificate and all. There are certain requirements for this labs also. So there only you have to get this certification done. Then only a product is valid to sell outside. So what happens if you want to book one test in this lab? Say for example ESD if you are booking, or radiated emissions RE if you are booking, it
Mm-hmm.
costs you 60,000 rupees for one day in certification. So that's why you do pre-certification and get everything done. Assume that you have to do some 10 tests like that. So it would cost you around 6 lakh rupees. Huh?
Yeah. Mm.
Huh. So that's why PCB designers are extremely cautious in designing the PCB, because they should not fail in the actual certification thing. So they have to do everything to get it passed. So that's why pre-certification test results are very important. So once you go for certification, you will once it get passed, you will push that to manufacturer, and then proto build development. Again, the customer will give the feedback. It will come back to the business and market research. You will start defining the product. There will be an existing product since you have already done that, and you will tweak that according to the feedback. This is an iteration process. This cycle happens 3 or 4 times to get it finalized. Okay,
Okay.
understood? Any doubts till point?
No, sir.
Understood, right? So first thing what they
Um,
ask is like, what do you know about product development life cycle? As an interviewer, I'm talking. So once they ask you how do you define this something called as PDLC, or where does the PCB designers comes into picture in the PDLC, you should be able to explain this. Okay.
okay. Yeah.
Okay. And all these things, so for everything you have certain standards. So there is
Mm-hmm.
certain standard for this PDLC also. It is
Mm-hmm.
like IEC 1562, no, just a minute. IEC 15288, sorry, 15288
Okay.
standards. This is for the software in systems and software engineering standards for this PDLC. Okay.
Mm.
And in certain automotive standards, they follow this V model. Here what happens is like requirements and testing, requirements and design and validation goes hand in hand. They start with the requirement analysis. Once they start with the requirement analysis itself, they will be focusing on acceptance testing. You know what is acceptance testing? Any idea?
Oh, no, sir.
Acceptance testing is done for the customer actually. You build a product, you take it to the customer, customer has certain requirements and he will test your product according to his requirements and it has to pass there.
Mhm.
That is called as acceptance testing. Okay. And
Yeah,
then
okay.
from the
Yeah.
requirement analysis, you come to high level design. From the acceptance testing, again, you come to validation. How do you validate this design? You need to know, right? And from that high
Yeah.
level design, you breaks down to component design. Some people call it as functional requirements also. At the same time, for each
Mhm.
component, how do you integrate that? Or how do you do that system, each component or each system testing? From this to detailed design, you will come from system testing to integration testing. So it is like top down approach. It is like you have big box, one big box.
Okay.
You start opening that box and see the smaller and smaller component. Okay, from integration testing to unit testing, from unit testing, from you will derive from requirement to high level design, from component design, from detailed design to implementation part. Okay, I got this detailed design. Now how do I implement? So from here your hardware design starts.
Okay.
So once the hardware design people says that okay, I need to implement this buck converter using LM7805, they will certain fix the certain components, they'll do certain simulations, they'll do certain calculations and all. Once everything is done for the PCB designer, then they'll come for the PCB designer. Okay.
Mhm.
So some automotive industries and some industries will follow V model also, not necessarily like this model. This one is like one phase they'll complete and then they'll move to other phase. This one is like parallelly requirement from acceptance testing to requirement analysis. Okay. So now you know there are PCB. There are multiple types of PCB that I will tell later. You know PCBs and its siblings, right? How do you connect two components? Everything here is about connection.
Mhm.
How do you connect two things? How do you connect two components or two circuits? So how do you do that? So how you can do it using direct connections, right? You can directly take a wire from one component and then you can connect to another component like it has to
Yeah.
work in theory. Yes or no?
Yes. Yes. Yeah.
And you must have used this breadboards in your college.
Ah.
Have you used this?
Yeah. 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 Yeah.
So you have used the breadboards also in the colleges.
Ah, breadboard, springboard.
Breadboard?
Yeah, breadboard also, even the springboards as well.
Huh, springboards, breadboards. And then have you used this one general purpose PCBs?
No, sir. I have not used this.
Okay, these are like you can place the components through hole components and then you can solder it from one side and then you can route it from the behind. This is the first
Uh-huh.
PCB step actually. So if you have any certain idea,
Okay.
you want to do a quick prototyping, you can use this. These are used for prototyping things.
Okay.
So this is the first step of PCB design. And from here on, there is no other thing. We will directly jump to PCB boards. Since these are the very basic things, nobody will cover this, so we will be directly going to the PCB boards. Okay.
Yeah.
Okay. Now, as I said here, like V model, so it all before see 90, not 90, say around 60% of your PCB is dependent on schematics. Okay. How do you come to the schematics from the customer to the PRD product requirement documents? From PRD to you will start deriving each and everything. PRD to specification, specification to block diagram to schematic. Okay. Because the
Okay.
reason why I'm telling this is like, see, if PCB design is 100%, 60% is given to schematics itself because the schematics will go to the stakeholders of the project. Stakeholders of the project. That means if you
Okay.
design some PCBs, you will not be sending the PCB document to the stakeholders. Stakeholders means you know that. What does that mean?
Owners.
Huh?
Owners for the company.
not the owners for the company. You are working in the project. Whoever is involved in that project are called as stakeholders.
Okay.
Okay, say a hardware engineer will be there in your project. So one hardware engineer, and then one signal integrity engineer, and then one mechanical engineer, and then one
Mm-hmm.
project manager. Okay, and then one engineering manager. So all these people are stakeholders. Once they ask you for like, okay, I need to know the schematics, because the schematics says more about your design than the PCB. Okay, if schematics is
Okay.
finalized, PCB can be done arams. I'm telling you, without any much headache, you can execute the PCB design. But in order for you to finalize the schematic, this itself is a big headache. Every single day,
Mm-hmm.
at least you will get 2 to 3 changes from all
Mm-hmm.
these people. Okay,
Okay.
so that's why schematic you need to be very good. Now let us come to the
Mm-hmm.
PRD, product requirement document. So actually, this document I'll show you. Just a second. Can you see the screen properly?
Yeah, yeah.
Yeah. See, this is an example of product requirement documents wherein you will be defining most of the things, like what is the problem statement, what is your product is about, who is tracking the progress, what is the objective of this product, what is the overview, what is the end goal of this, what is the success metric. Say, for example, you want to achieve in 7805, you want to achieve 5 volts. You got some 4.5 volts. What is the success metric of this? Can we sell it or not? So it all, like all of these, what is the scope? See, you cannot give this product to some what do you say, some NASA guys. Can you give this product to NASA guys? No, not possible. It has its own scope.
Mm-hmm.
So whoever whom you can sell or whoever can use, that will be given here. And then non-functional requirements also there. Do you know what is non-functional requirements? Say, for example, I want this product to fit like this properly. It has to be in this shape only. It has to be stored in
Mm-hmm.
this temperature. So these are all non-functional requirements. Functional is how it works. So what is the metric for this?
Okay.
What are the use cases? Who all are dependents, and what are the dependencies and constraints? Say, for example, this is a hard deadline. This is a dependent, and these are the constraint. It should not cross 2 ampere, but it should not come less than 0.5 ampere. That is a constraint. So there are so many questions. If there are any questions, additional considerations. So these are the product requirement documents. These are like too much in depth of all that. Okay.
Okay.
So especially here in that PRD, it comes functional, power supply, mechanical, environment, regulatory, reliability. Majorly.
Okay.
Functional means like what does that product do when it comes, if this is a hardware design course, it would take like so much time for me to explain this also. Say, for example, you have a microcontroller. I'll just give you one example. What is a functional requirement? Do you know what is functional requirement by any chance?
No, sir.
Okay, say for example, a customer says that, well, I will turn on the switch, okay,
Okay.
and this bulb has to glow in zero point 0.5 seconds. This is a functional requirement. So when you turn on the switch, this LED has to glow. Okay,
Okay.
not LED. The actual bulb has to glow. So how do you design this? This is a function of this product. So that is the functional requirement. And then the supply voltages, how much current it draws, what are the IO logic levels, and these are all very important for you when you're designing the PCB. And I'll tell you why while designing the PCB. I'm just giving you an overview now.
Okay.
Okay, and from the mechanical team, you have multiple people giving you the requirements, like the PCB should be like this shape only. Okay,
Mm-hmm.
so when they say that, because they have certain fitments, assume that. they have certain fitments. So they give you that this has to be in this shape only. Then how you place the connectors. So how the connectivity between system and your PCB, input output. So mechanical requirements should also very important. Then environment. Assume that you have designed this PCB and it works at 25 degrees centigrade properly at room temperature. But when you take it to 50 degrees centigrade, say for example in a condition like Raichur and all, it doesn't work. What is the use?
Oh,
Right? It has to work. It has to work at a wide range of temperature. So that is the temperature,
okay.
environmental requirements. And then regulatory. This, so in PCB design, this is the most important part, because in order for selling of any of the products, you need to pass these regulatory things like restriction of hazardous substances, REACH requirements, Underwriters Laboratory, CE, ECC, and all that. So there are extremely useful guidelines on how do you meet these requirements while designing the PCB. That this PCB design course is also going to focus. Okay.
Yeah.
And apart from that, certain reliability requirements. So it has to work for 3 years, and then warranty, MTBF, mean time between failures, and derating rules, burn-in test plan. So all the requirements are documented in the PRD. Okay.
Mm-hmm.
And we will also be doing this PRD at our level. So once you start going to the company and they will ask like, okay, what is the PRD and how do you define it? You should be able to know like, okay, this is how the PRD is. From here on, what the inputs I have to take as a PCB designer to design my board. Okay.
Okay.
And apart from that, what else is required at the high level? This is not this is at very high level, power budgeting. So you have like 10 circuits in one board. Okay, assume that you have 10 circuits in one
Okay.
board, and each circuits
Mm-hmm.
draw 0.2 ampere of current. So 0.2 into 10 means total 2 ampere of current. So for this 2 ampere of current, the trace width is good to carry this currents. The trace widths are good. So for each and every connection, the trace width is good that you have to define. And then for the total 2 ampere, so at any given instant of time, the board will be carrying 2 ampere of current. For that much, the board, how much it will get heated up, and are there any heat sinks are required? That is a thermal consideration. So for that, you have
Mm-hmm.
to think in terms of PCB designer. That you will get to know. And this one, the most headache part. There are multiple types of PCBs, Jawad, like IO type of PCBs, like microcontroller type of PCBs. Okay. And high
Okay.
speed designs
Okay.
also. Multiple types of PCBs come. I will explain that later. In
Yeah.
especially in the high speed designs, these things are very
Uh-huh.
important, like protocols like I2C, SPI, and then Ethernet, USB, high speed protocols also, Ethernet, USB, especially this DDR, RAM, and all. So those protocols, and there's voltage levels, pull up, pull down requirements, signal integrity requirements. That is the most headache actually compared to normal IO circuits and all the other stuff. Okay. So this is
Okay.
completely about the requirements and product development lifecycle part. You can just think through and ask me any of the questions if you have. Please take your time, not an issue.
Okay.
Aram se, just think that okay, what the thing I need from here and what the interviewer can ask, whether all these been
Mm-hmm.
covered or not. Okay, just think in terms of, because you're paying so much, you should be, you have the all the rights to ask me like, okay, what is this and what is that? Yes or no?
Yeah.
Yeah, just think through.
So, yeah. So coming to the schematic part,
Hmm.
you told if you are covering schematic, you can easily make the PCB. So how
Can you come again, please? I
if
could
we
not hear you.
the schematic, I told
Yes.
it's kind of a bit
Hmm.
difficult part in this.
Yes.
Uh, so
Hmm.
we have a kind of board with us,
Hmm.
PCB board,
Hmm.
and we want to make a kind of assume that already we have PCB and we don't have a schematic. We are directly placing the components and we are
Hmm.
building it. So how do we don't have any tracking and we'll be like, is it necessary that schematic is for beginning for demo purpose? We need any schematic
First of all, yes.
for projects.
Yes, yes, yes. Schematic is
Mhm.
must and should for any project. Must and should.
Okay.
Okay.
Mhm.
Assume that it is a small board. Say, I'll show you. It is a small board where you can see the tracks, how it is connected. For that, you don't
Mhm.
need to have schematic. I'll tell you why schematic is essential. Just a minute. Uh, just so this is the Altium Designer tool itself. Okay. See, this is the board. Okay. You
Mhm.
tell me what does this board do actually in real product?
This might be. This is a processor. What we can see in between in
What
the middle
processor is that?
uh, might be uh, computer CPU.
No.
Uh,
I give you this board. Okay.
Microcontroller. Okay.
Are you sure this is microcontroller board? I'll give you this schematic.
No, no.
Okay.
Okay.
I'll give you
Uh,
this board itself. Can you identify what
it's
is
like
this?
Arduino board. Not an Arduino.
Hmm.
This look. in a software.
Hmm.
So there is an error.
Hmm.
So still we have not completely designed our this thing. I mean, deployed or designed to a physical board or something.
Hmm.
So still the costing is going too high. How is it?
No,
So in
see,
software itself, we could have recognized the error. No?
whatever you design the PCBs, they will put it something called as ATE, Automated Test Equipment or Test Automation System.
Okay.
There they will run the test. Wha-
Hmm.
I did not say that the issue will come only because of PCB. Yes or no?
Yeah, yeah, yeah.
So these are the issues that can come because of the PCBs. There are many other issues
Mhm.
apart from these also, right?
Ah,
Okay. So whatever that issues come because of PCB, you have to rectify it.
okay, 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 okay.
That is what this intent is.
Mhm.
Maybe because of the software, maybe because of some other thing. That is highly possible.
Mhm. Okay.
Any other questions?
Mm, no, sir.
Okay. I just wanted to understand, like, did madam told you like continuous, I mean, throughout the week, every hour the classes will be there, or
She
only
have
three
not
days?
told me nothing like that. She did not tell anything about the class or something. Even I did not ask her anything.
Okay.
Uh-huh.
So how you want to like go ahead? Are you okay every day 1 hour or 3 days per week?
Uh, 3 days per week. And what will be the timing if you're going 3 days per week?
Like
Every day,
8
what
to
will be
8 to 9:30.
8 to 9:30?
Yeah. So I
Okay.
can take 1 hour every day in a week, or I can take
Mm-hmm.
3 days per week. And weekends will be like again 1 hour only. I don't want to like put everything and then it will not be good. But
Yeah.
certain practice sessions
Uh,
and all, certain layouting sessions and all, we may have to sit for more time. That at that time we will see. But for theory classes and stuff like this, I think 1 hour per or 3 days per week is enough. What do you say?
yeah, we can go with 3 days per week.
Huh. So no, think about this and just let me know.
If you are doing 3 days per week, we'll be extending till one and a half an hour extra, right?
Yes, 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 1.5 hour. Not
Hmm.
necessarily 1.5 hour. Whenever I want to cover that concepts, even if it is two
Concept.
hours also, I'll take it. Okay.
Yeah. Okay, we'll go with the 3 hours, 3 days per week.
Sorry, like some noise in
It,
the
it,
background.
actually, so
Hmm.
actually, I told 3 days per week will be better.
So 3 days, 1.5 hour sessions per week.
Hmm.
Okay. Please discuss this also with Hema ma'am once, okay? Because you and her, you discuss and then let me know. But your option is this one: 1 hour per day
Mm-hmm.
or 3 days per week, 1.5 hour each. 1.5 hour is minimum.
So if we are doing 1 hour per day,
Hmm.
so is there anything that we will be winding up the uh, training early? And if we are
Uh,
doing 3 days per week and we are dragging for a month
No, 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 no,
late,
no.
something.
Here the hours doesn't matter. Here the concept will matters. How you tell the concept. Assume that I'm
Mm-hmm.
taking 1 hour per day. Concept is good and certain things I have to explain means it will even extend also. If 1.5 hour per day, sorry, 1.5 hour per day if I'm taking like 3 days per week I'm taking. If the concept is completed, then I can even leave it at one hour also. It depends on the concept, not on the hours, but majority of the concepts are laborious and like very lengthy also.
Mm-hmm. So till what? How many? So will this course go 2 months or 3 months?
2 months,
Okay.
60 hours.
And offline, is it possible weekends offline?
That is what I
Sunday.
was expecting actually. If you can come offline, it will be easy for me to tell you in terms of, especially in terms of layouting.
So
You know the center,
offline,
right? Weekends for coming.
yeah, yeah. I
Hmm.
know the center, but
Hmm.
I will be off on only Sundays,
Hmm. Hmm. Hmm.
and it will be like 10 to 2. We are coming on Sundays, 10
Where do
p.m.
you stay, by
p.m.
the way?
I stay by another.
RR Nagar.
Yeah.
Okay. Sorry, you were telling like from 10 to 2, it's easy for you to come on Sundays.
Huh.
Fine then, sure. You better talk all this to Hema ma'am, okay? Because she has
Okay.
to make the systems free and all. You have a laptop, right?
Yeah, yeah, I have a
Does
laptop.
that contain GPU?
No.
Then how with respect to Altium? Can you better get your laptop this weekend to the center? I want to check that. We'll install that Altium inside your laptop and check.
Fine. Yeah, we can do.
Huh, fine
I
then.
think I
Yeah.
have integrated GPU of two. Let me check what is the
Please check,
integrated
please check.
GPU.
If you have the GPU, it will be easy because it takes lot of graphical processing units also.
What is the
Otherwise,
basic requirement for?
for me.
Yeah, sir. I'll definitely talk to him on this,
Mm.
and yeah, I'll confirm you by tomorrow.
Okay. Thank you so much,
Yes.
Mohammed. Then, can I call you Mohammed directly or Javed would be fine?
Yeah, it's your wish, sir. Both works.
Okay, fine. Thank you. Thank you. Then, see you tomorrow.
Thank you, sir.
Bye.
Thank you. Good night. Bye.